Functions. We need to come up with a definition for what a function is. You should be able to leave this class knowing that piece. We're going to use Gina and Owen as an example. You guys are playing some hockey, okay? If you guys were to hockey one-on-one, who would win?
Probably Owen.
Probably Owen, but maybe not. Suppose instead of hockey, you guys playing against each other, suppose you guys were on a co-ed team playing with each other, okay? I want you guys to think about this situation. Is it possible that they both play on a co-ed hockey team and they both score 0 goals in a game? Is that possible? Is it possible that she scores 1 and he scores 0? Is it possible he scores 4 and she scores 2? Is it possible that they both score 10? It's not likely, but it's possible, right? I mean, maybe they're playing against some 4th graders, you know what I mean? Like 4th graders are crying because they're getting beat so bad, and they're laughing and saying, "Ha, take that, little brats," you know what I mean? So, you know, that, who knows how it's going, but it is possible. Is it possible for Owen to score 5 and for Gina to score 1 and 3? Like if you saw this, somebody said, you know, hey, Owen, how many goals did you score? He said, I scored 5. And he said, Gina, how many goals did you score? And she said, I scored 1, and then I scored 1 and 3. Like, oh, so did you guys play 2 games? No, I played 1 game. So how many goals? Well, 1 and 3. So did you get 1 in the first period, and then 3 in the what? Everybody agree that would be confusing? Because she's the input, he's the input. The output is the goals. And do you everybody agree there's only one number that you can output for goals? She can't output multiple goal numbers. That's the definition of a function. The simple definition is this. Every input, and input is what we refer to as our domain, has exactly one output. That's your range. Simple as that. So when we look at it from a mathematical sense, we have examples here of coordinates in which we have domain. Domain is the x values, and my x values are 1, 2, and 3. My range is going to be the y values, which are 2, 5, 7, and 8. And I'm going to do a mapping exercise here to see whether or not this is a function. I have my domain and I have my range. 1, 2, and 3 for the domain. 2, 5, 7, and 8 for the range. Okay? It says 1 goes to 2. It says 2 goes to 5. It says 3 goes to 7. And it says 2 goes to 8. Talk to the person next to you. Do you think this is a function, yes or no? And why or why not? Okay, go talk. What do you think? Take a guess. I heard some good discussion here, and I want to point this one out for you. Notice that this one has, sorry about that. I duplicated that one by accident. We're just going to look at these 3. This one has a domain of 1, 2, and 3. What is the only range value?
4.
4. Is that a function? This one is not a function. And here's why. Gina is like player number 2. She can't score both 5 and 8 goals in a game. That's not possible. However, Owen, Big Dop, and Gina they can all score 4 goals in a game, can't they? See the difference? So it's not whether or not the left and right are uneven in terms of the number of terms. It's that they all correspond to just one spot. That one goes to one spot, that goes to one, that goes to one. Function, yes. This one, 2 goes to 2 different spots. Can't happen. So the domain, you can never have domain where you have more than one arrow going away from it. Okay? Look at number 2. I have domain values of 3, 5, 7, and 12. I have range values of 6 and -1. Okay? So as I go to my mapping, I have 3, 5, 7, and 12. And then I have -1 and 6. We said that 3 goes to 6, 5 goes to 6, 7 goes to -1, 12 goes to -1. You've now seen 2 examples. Is this a function? Yes or no, and why? Talk to the person next to you. What do you think?
Yes. It's because the domain is gone. Twice.
This is yes. Okay? Gina can score 6 goals in a game. At the same time, Owen can score 6 goals in a game. Big Doc scores -1. He put the puck into his own net. And Goy put the puck into his own net as well. Okay? So, sorry. I'm trying to hate on y'all. But yeah, so this is totally legit. That can happen. I'm not going to write anything down for example 4. I simply just want to look at it and talk to the person next to you. Do you think the last one is a function? Yes or no, why or why not? Okay, go talk.
Because this person can't score -2 and 7. Because there's 2 ones for the domain.
Nunu, what do you think?
No,
How come?
because the domain, you can't have the same number twice.
Yep, I heard you say one goes to 2 spots.
Mhm.
Gina cannot score -2 goals and 7 goals in a game. That is not possible. Okay? So you should be able to look at something to determine whether or not it's a function by looking at the data. Another way to determine if something is a function or not is to be able to perform what we call the vertical line test. So suppose I had a graph that was in blue, and then I have another graph that's in red. Okay, those are my 2 graphs. I'm going to test to see whether or not these are functions. And the way I do it is I take a vertical line and I drag it across. Look at the blue one. See how it crosses just once here? Now I move it here, just crosses once, just crosses once, just crosses once. That means this is a function because it only crosses the graph once in every spot. Whereas for the red one, it crosses twice. So therefore, the red one fails to be a function, and the blue one is a function. Okay? So we flip it over. We want to go through about 8 of these examples. And you guys can work, but this is determining the domain and range and whether or not it's a function by looking at it graphically. We've had a little bit of a background, and now here we're going to go. Okay? When I list the domain and the range, we need to understand this notation. If I were to write this down, wow, really struggling. What this means is this means the numbers 2 and 5. That just means the numbers 2 and 5. That's it. If I write down this means every single number between 2 and 5. It means I include 3. It means I include 4.5. It means I include 2.001. So everybody agree that there's an infinite number of numbers that sit between 2 and 5? I'm including all of those. This one, only the numbers 2 and 5. That's it. This is called roster notation. This is called interval notation. If I put a parenthesis, this means I have the numbers between 2 and 5, but not 2. I have the number just to the right of 2, like 2.000000001. I have that number and everything on over to 5, but I don't get to include the number 2. Okay? All right? So, domain. Notice I just have the x values of 2, 3, 6, and 7. Those are the x values for those coordinates. So that's my domain. Because they're specific points, I list it as a roster. The range is the set of y values. The y values start at 2, 3, 4, 6, and 7. That's my range. Is it a function? Does it pass the vertical line test? Where does it fail?
C and D.
C and D. Vertical line, you got 2 points stacked across each other. See, 6 corresponds with the value of 2, and 6 corresponds with the value of 4. That means no, it is not a function. I look at the next one. The domain is the x values of 1, 3, 4, and 5. The range is the y values. That is 1, 2, 3, and 5. Is it a function? Yep, if I draw a vertical line, you can see that each point only hits once. So yes, it is a function. We move to this one. Notice how this one is a shape. Okay, it's a 4-sided shape. Let's do the obvious piece right away. Is this a function? No, it's not. Let's list the domain. And by the way, as we list the domain here, I would estimate that 50% of students would get this wrong on the test. But you guys are an elite level, so we're not going to have that, right? So let's watch. When we do domain, domain is x, so it's sideways. As I move from left to right, what's the first x value I pick up? 0. And since it's a connected graph, I have every value in between. So I'm not going to use roster notation. I'm going to use interval notation. So I start with 0. What is the last x value that this shape reaches?
8.
8. Everybody see that? Goes all the way over to an x value of 8. For my range, that's the y values. I start at the bottom and I move up. What's the first bottom value I hit? 0. And I go all the way up to what's the last y value I hit? 4. Is the next one a function? Yes, it is. It passes the vertical line test. My domain is my x values. It's a connected graph, so I'm going to use my intervals. What is the first x value that I pick up? -3. And what is the last x value that I reach? 2. For the range, I start down here. What's the first range value I meet? -3. And what is the last range value I meet? A y value of 4. We're going to do 2 more together, and I'm going to have you do 2 on your own, and that's where we'll stop today. These are different because we see arrows on the end, and we just want to talk about conceptually what that means. I'll list my domain, and I'll list my range. Right? The arrow means it continues on forever in that direction. Okay? So see how it's headed on forever like that? So what is the number way over here that it's approaching? -infinity. So the domain is going to start at -infinity. And then you can see the arrow go on forever that way. So what's the number way on over to the right? +infinity. Now we can think about this as left and right, but we can also think about it up and down. It's headed down this way forever. And so the range is going to start at negative infinity and go up to positive infinity as well. The second one is similar, but it is slightly different. Notice how we have arrows on the end. That means it goes forever in each direction sideways. So the domain is from negative infinity to positive infinity. But how about the range value? Does the graph ever go down to negative 10? Does it go down to negative 5? Negative 4? Negative 3? Yeah, and does it actually hit down at negative 3? Yeah, so we're going to say negative 3 is where it starts, and that heads off to infinity. Notice we put a parenthesis on infinity. You never put a bracket. You can never contain infinity. It's unbounded. There's always something that's bigger than the next number. So these, I would say, are two great examples of ones that you would see on the test. So this is where we want to all do one with you, and then you'll do one on your own. My domain, where do I pick up the first x value?
5.
Close, that would be the y value. Pick up the first x value at 2. And then it heads on off to the right, so it heads off to infinity. The y values I pick up at 5. And then they head off to infinity from there. So you've seen more examples. I want you to try this last one on your own. Please just list the domain and the range. So you can apply your thinking to try that one on your own. The domain should be from negative infinity to positive infinity. And the range is going to start at negative 2 and go on up to infinity. So in our algebra class, we focused a lot on x and y and variables and expressions. I would say that as you continue on in a college algebra class, we talk a lot more about graphs analytically and what that means. So what we're going to do on Monday, and I want to be clear, again, this is probably one of the pieces of the test people get wrong most often. And I don't want that to happen for you. So on Monday, I'm going to put 6 graphs up here, and we're going to review it and try it together. But you can definitely start your homework, and I'll be clear about the expectation on the homework, okay? For the homework, the first part, all you need to do is just answer yes or no, are they functions or not? Now, as you go through, if you say no, make sure you have an idea in your mind as to why it's not, okay? You don't have to write it down, but I'm just saying, try to make sure you're understanding why. If you're confused about why, then let me know. On the second page, there you identify the domain and the range and whether or not it's a function. To be clear, number 16, that is the shape of a triangle. So it's not just this, it's that. So it's got the bottom to it. Okay. And that's that. Okay. If you want to work on some of that, you sure can. Or you can wait till Monday. But this is the last unit of stuff that we will be doing. everybody make sure you bring a gift on Monday. Big Will has a birthday on Monday.
I thought it was a joke at first. I thought it was a joke.
Oh, can you press the red dot? Oh, there you go.